Hi, today we'll be going over the 2004 free response exam question. It states, iron reacts with oxygen to produce iron oxide by the equation. A 75-gram sample of iron is mixed with 11 liters of oxygen at 2.66 atmosphere 98 Kelvin. A states, calculate the number of moles of each of the following before the reaction begins. To find the number of moles for iron, we can take the mass that was given and divide it by the molar mass from the periodic table. This tells us that 1.34 moles of iron were used. Now for part 2, it states calculate the number of moles of oxygen. Now in the given, it gave us the volume, the pressure, and the temperature. So we can use PV equals nRT in order to find the number of moles of oxygen. And so you the volume and divide it by the gas constant and the temperature, and it calculates to equal 1.25 moles of oxygen. Now question B states, identify the limiting reactant when the mixture is heated to produce iron oxide. Support your answer with calculations. Now you can take the number of moles of iron, which is 1.34, and multiply it by the molar ratio, 1.5 moles of oxygen over 2 moles of iron, and this calculates to equal 1.01 moles of oxygen would be used with this amount of iron. But as we calculated before, there were 1.25 moles of oxygen initially, so there's leftover oxygen, which shows that Fe is the limiting reactant. Now to question C. States the number of moles of iron oxide produced when the reaction proceeds to completion. So here we take the limiting reactant of iron and multiply it by the molar ratio from the balanced equation, and it calculates that 0.67 moles of iron oxide are created. Now D, the standard free energy of formation of iron oxide is negative 740 kilojoules per mole at 298 Kelvin. It states, calculate the standard entropy of formation of iron oxide at 298. Include units with your answer. So here we can use and go home to supper. And if you do all your calculations correctly and solve for the standard entropy of formation, it will equal negative 0.28 kilojoules per mole Kelvin. Now part 2 says, which is more responsible for the spontaneity of the formation reaction at 298 Kelvin? The standard enthalpy of formation or the standard entropy of... Justify your answer. Now, we know that the standard enthalpy of formation, H, is the more important factor because it's exothermic, which favors spontaneity. The standard entropy of formation is negative, which means the system becomes more ordered as the reaction proceeds. Greater order will not increase the spontaneity of the reaction. On to E. Calculate the standard enthalpy of formation, delta H, of iron oxide. So here we can use the equation delta H reaction equals the sum of delta H products minus the sum of delta H reactants. So you can plug in your numbers and solve for delta H F iron oxide, and you should get it out to equal negative 272 kilojoules per mole. So I hope you're good.